Project 3.2.2, SAR ADC, DAC R2R ladder, sample and hold circuit, and ADC comparator. In this phase, the SAR ADC's DAC R2R ladder, sample and hold circuit, and comparator are set up using simulating devices such as rocker switches for the DAC and a potentiometer and logic sample and hold button for the sample and hold circuit.
So this is the SAR ADC DAC and sample and hold circuit. As you can see right now, we have a DMM. It's hooked up to the comparator here, which is showing the voltage difference between the DAC over here and the sample and hold circuit output right here. I'm holding this button down over here because that's giving me a live reading from the potentiometer. If I were to release it, the voltage output from this would slowly drain because the sample and hold circuit's not 100% perfect. But what essentially it is it's a latch that stores an analog value from an input, and no matter what I change this, it's not going to change drastically. It's just going to decrease at the rate it's already decreasing at. But if I change this to like a let's say a significantly lower value than it was originally at, then press this button, the voltage is going to reset to whatever voltage is over here. So let's just see that there. So it's a smaller initial voltage value now into the millivolts, and as the voltage difference becomes negative, this LED goes out as the output here is fed into the comparator, and the DAC voltage becomes greater than the sample and hold output voltage. So this is a Falstad simulation of the sample and hold circuit. I made it to sort of build a representation of what the sample and hold circuit actually does. It's not a perfect representation, as this switch here is supposed to be connected via TTL logic according to the data sheet, and this capacitor will leak voltage while it's in a hold position. Right now you can see it's in hold position as the switch is disconnected and the input voltage does not equal the output voltage. And I can change this input voltage to whatever the heck I want, and it's still not going to change this until I latch it together. And then I can delatch it, change this again, latch it again, delatch it, and swap, latch it again. And this is essentially how the successive approximation register will work. With each time that the 7th bit of the register is assessed, after that this switch will pulse or toggle, and then the output of the sample and hold circuit will match whatever the input is for the following reading. So the objective of the SAR ADC, once it's fully completed, is to be able to match the voltage between the DAC, which at this stage is currently supplemented by these rocker switches and resistor ladders, with the sample and hold circuit output. Right now I'm holding down the sample and hold latch so that it's outputting the live feed from the potentiometer, about 2.15 volts. And then I'm just gonna mess with these switches to see when I can get an even voltage. And when that even voltage occurs, this will go to 0 or about 0, and this LED down here will either dim or turn off or flicker. It'll be on if the voltage here is greater than 0, and it'll be off when the voltage is less than 0. So the closest I can get to the input voltage feed is about a difference of 0.358 volts, and currently that difference is lower on the DAC side than the potentiometer sample and hold side. If I were to change this, and we'll go through that process again, and watch as I'm changing the switches. I'm going from right to left, which is essentially the same way that the SAR ADC will perform its operations. Like I said in the previous video, it's sort of a guessing game where its only answers are it's higher, it's lower, or it's equal to, but it's never going to be exactly perfect. So that's the closest voltage reading I can get to in comparing the DAC and the sample and hold circuit at a difference of about 1.61 millivolts.
Thanks for listening.